Alright, hey everybody, welcome back to Intraz. In this video we're going to be talking a little bit about path engineering. Basically we want to see how to send traffic an alternate path. So we're going to be looking at router 1 and we want to ping router 4. So we're going to start over here on router 1, it's going to go through 2 and then of course to 4. We know this is the case by default because if we come over here and we look at router 2, you're going to notice I already did a show IP route, and the 4.4.4.4 from the perspective of router 2 is the next hop, router 4. We also did a trace route to show that of course there's no hops in between. One of the things we also need to do is come over here to router 1. And you're going to see we do our trace route and it goes to router 2 and then directly to router 4. So currently we have it from 1 to 2 to 4. This is not actually what we want to accomplish. What I want to accomplish here is I want to take traffic that originates from 1, it goes to 2, heads over to 3, and then down to 4. This is something we can basically consider as traffic engineering. So once again, traffic engineering is a method of, changing paths based on, certain criteria. In this case, we want to go from 1 to 2 to 3 to 4, because let's just imagine the link between 2 and 4 is something really bad. So maybe this is a T1 or a fractional T1 or something like that. And on the links between 1, 2, 3, and 4, I would say the minimum bandwidth, for those who understand ERGRP, is going to equal, say, 10 meg. So that's the minimum bandwidth across all links. Of course, having this, T1 with the 1.544 meg is a lot smaller than 10 megs, of course. So if we have a gig link here, a gig link here, and a 10 meg link here, you're going to notice, well, that would probably be the better path to take. BGP, of course, doesn't work that way because of our path selection process. So what we need to do is we need to think, okay, well, BGP path selection, at least in this case, is kind of a per hop kind of basis. So we have a couple of different options here. Now, one of the easiest ones to do, and one of the ones you'll see in Enterprise, is something called PBR, or policy-based routing. Policy-based routing is really cool because you can change the next hop using policy. The other one we have is changing the weight and local preference on whichever router needs to, change its path. So if we come in here and we look at the weight, and by default, of course, that is 0, and then the local preference, which is 100. So let's just verify that really quick on router 2 that we still have our BGP routes. So show IP BGP. You're going to see that the connectivity to router 4.4.4.4 has a local preference of 100 and a weight of 0. So one of the things we can do is we can come over here to router 2 and change the local preference or weight on the interface that receives said route. Now once again, this only works because we changed router 3 into the route reflector. So if you remember before, and based on what we're looking at here, 4.4.4.4 actually has 2 paths, 3 to 4 and 2 to 4. So once again, 3 to 4 is this way, 2 to 4 is this way, and this is the path we do not want to use. So we want to make sure we can go, kind of a roundabout kind of way. So one of the first things I want to do here is say, okay, let's go the easiest route. Let's stay with PBR for the time being. So let's see if we can figure out this PBR thing. We come over here to config terminal, and for PBR we need to create an access list. Alright, so IP access list extended 100, 10, permit IP any to host 4.4.4.4. Once again, simplistic design, just showing you how it works. Alright, we have our access list. Go into 4.4.4.4. Now we need to create our route map. So what a route map does, it allows us to modify a lot of different conditions around the network. In this case, I am going to be doing, let's see, PBR for 1, 2, 3, 4. Let's just do that. So technically we could have put a permit 10 on there, but we only have a single route map entry, so we're just going to match IP address 100. And here's where we're setting the next hop for IP to something. Now in this case, we want router 2 to forward to gig 1 on router 3. So over here on router 3, we need to verify the configuration. Show IP interface brief, exclude unassigned, gig 1, 23.23.23.2. So that's what we're going to have here, 23.23.23.2. Alright, so once again, let's verify over here on router 1, trace route. It still goes from 1 to 2 and then 2 to 4. So let's come over here now to another interface, show IP interface brief, interface gig 1, IP policy route map, and the word of the route map. So in this case we have the route map, PBR underscore 1234. If we come in here and do a question mark, you're going to notice there's nothing after that. So because we're changing the next hop, let's come back over here to router 1, do a trace route, and now you're going to notice that the ping goes from router 1 to router 2 to router 3 to router 4. So, I mean, this is not a BGP thing. This is just a PBR thing. So keep that in mind. A nice, quick, easy, simple way of doing things. All we have to do is find the interface and then, just create the access list that we're going to use. In this case, permit IP any. So any traffic that hits gig 1 destined for 4.4.4.4 is going to take this route. So it's going to affect no other traffic except a destination of 4.4.4.4. Alright, so moving on, interface gig 1, do show run interface gig 1, no IP policy route map. Alright, we'll try it again to make sure we're good. And now it's back through 1 to 2 and 2 to 4. So we can come over here on router 2 again, and this time we're going to be looking at weight and local preference. So let's see, let's create a route map called WR3, and once again you have the permit and deny and ordering statements, but we only have one entry, so we're just going to hit enter, and we can go set. And you're going to see here when we hit set, we can change the BGP local preference, BGP extended communities, route flap dampening, community lists, AS path attributes, and of course weight. So we're going to set the BGP weight to a certain value. Now once again, what is weight by default? Well, it's 0. So I mean, we could just come in here and say 1. That's it. Let's create a second route map called LP. So we have W-R3 and LP-R3 set local preference, and once again the default local preference is 100, so I'll choose 101. And that's kind of it for our route maps. So what we have to do when it comes to weight and route maps, we have to go back into BGP 65001. Let's see if we can do our neighbor statement. Let's see, 23.23.23.2. We're going to specify the route map, if it lets us. But it doesn't look like it's going to. So remember, if there's an address family configured, you have to go into address family for this to work. So 23, okay, route map, there you go, W-R3. Of course, we have incomplete command, so we actually have to specify in or out for the incoming routes or the outgoing routes. In this case, it's an incoming route because R3 is telling R2 how to get to R4, so it's incoming. Once we do this, we can do show IPBGP again. And what we're going to be looking at is the route for 4.4.4.4 coming from 2 to 3. So let's just verify, and then we may need to restart BGP. So neighbor 23.23.23.2, route map WR3N, and now you're going to notice the weight has been changed to 1. So before, on 4.4.4.4, we saw we had 2 routes, from 2 to 4 and from 3 to 4. So these 2 links told us how to get to 4.4.4.4. Coming down here, you're going to notice that from 2 to 4, it's weight of 0, and 4.4.4.4 has a weight of 1, and 3.3.3.3 also has a weight of 1. So this can be some unforeseen consequences here because all routes going to router 2 from router 3 are now going to have a higher weight. In this case, 3.3.3.3 now has 1 as well. From here, let's come over to router 1, show IPBGP. You're going to notice that weight doesn't exist here because once again that's, a local type of thing. If we do a trace route for 4.4.4.4, you're going to notice now that we are indeed using router 3 to get to router 4. So back over here on router 2, do show route map. We have our weight, PBR, and now we have local preference. It's going to kind of be the same thing. We love all our mothers, so weight is precedent. If we changed local preference now, it would not matter because weight takes precedence. So what we can do here, come back into BGP, and we can remove the neighbor statement for route map W-R3N, and we can do the neighbor 23.23.23.2 route map, was it LP-R3N? Once that's done, weight will go back to 0, but local preference will go up. And like I said, it'll take a little bit for this change to take effect. And here you're going to notice now that the local preference for the 3 and 4 networks are now 101, and weight is back down to 0. So back over here on router 1, we do our trace route, and you're going to notice it goes 1 to 2 to 3 to 4. Yep, that's kind of it now. We did our PBR. We specified a policy for any information coming into gig 1. Destination 4.4.4.4 will have a next hop of router 3. BGP, of course, we came through and said any routes learned on gig 2 will have the weight or local preference changed, and that will change the IPBGP path selection. Weight, local preference. So one of the last things we can do, just to play around a little bit, let's look at our BGP configuration. Right now we're using LP-R3 in. So let's end data here. Route map LP-R3 set wait 1. All right. Show run section route map shows us our configurations. We're going to be setting both local preference and wait. Show route map does kind of the same thing, except this actually shows us matches such as packets and bytes. So show run shows us the config. Show route map shows us the actual matches, how many packets and how many bytes. And you can also just, call it directly. In this case, it has the match clauses and it has the set clauses. Once this is done, you can come over here and see that BGP and local preference have both been set. Now keep in mind, you can do this especially if you're working with a lot of traffic engineering stuff. Traffic engineering comes into play quite a bit when you're looking at some of the newer MPLS technologies, and MPLS typically relies on BGP, so understanding some of the, experimental traffic engineering of MPLS and the BGP path selection, it can always be very helpful. Now once again, in case you forgot, I want to remind us, we love all our mothers. So you have wait, local preference, locally originated. Now keep in mind, the locally originated and origin are two different things. AS path, origin, and med. So we will be talking about all of these in the next few videos, but as far as we're concerned with iBGP, this is kind of it. Wait and local preference. One of the things I wanted to see or show you really quick is you're going to notice this path right here. So the path is question marks and eyes. So when you're looking at pathing in BGP, it acts a lot like RIP. And the reason why we mention AS path here is because, well, when you're dealing with a system like RIP, it's based on hop count. So as an example, we are on 65,001. So 65,001. As a packet traverses service provider networks, you're going to see this AS path have additional numbers to it. And this path, of course, tells us which autonomous system numbers it went through to get to us. This is also another cool traffic engineering thing that we can talk about when we get into eBGP. Because once again, iBGP is within a single or the same autonomous system. Hopefully you'll stay tuned for that, and we'll see you in the next one.